Welcome, everyone. My name is Shashikant. Today, I'm going to talk about what I think is the most exciting area of improvement in PostgreSQL 18, vacuuming. If you ever dealt with the PostgreSQL database in production, whether that's on Azure, on-premise, or anywhere else, the changes which we're going to cover today directly affects how your database handles bloat, freezing, and overall maintenance. Now let's dive into vacuuming enhancement in PostgreSQL 18. What makes it faster, smarter, and more predictable? Before we get into PostgreSQL 18 specific features, let's first understand why vacuuming is so important in PostgreSQL. Vacuuming is a PostgreSQL lifeline. It helps to reclaim the storage from the dead tuple that has been created by the update and delete statement. It also helps to prevent the transaction ID wraparound situation. In case if you've never dealt with this situation, it's one of those emergencies where it can put your database into the read-only state. Part of the vacuum is also analyze, which can keep the query planner stats accurate. That helps in overall faster query executions. When you have a poorly tuned auto vacuum, that can lead to a table bloat, degraded query performance, and it can even lead to a wraparound situation. The wraparound emergencies has been now reduced since the release of PG14. But if someone is not paying attention to their vacuuming cycles on PostgreSQL, this can still happen. PostgreSQL 18 delivers the most significant collection of vacuum and analyze improvements over the years. What we are talking about is the faster I/O, dynamic scaling of auto vacuum workers, smarter way of triggering the auto vacuums on tables, better observability. Now, all of this is production ready in PG18. We're going to cover all of these features in more details in upcoming slides. In these slides, what we have is on the left-hand side, what we described is the pain points which we had prior to PG18. And the right-hand, what we have is how PG18 addresses all of these challenges. So before PG18, vacuums were blocks on the synchronous read. So it has to wait for an IO to complete, then wait for the IO to get complete, process it, and then again redo the same thing. Changing the auto vacuum max worker requires a full server reboot window, which is not even possible for busy production days. There was no hard caps on the dead tuples, so the larger tables accumulate millions of rows in bloat. The normal vacuums were skipping all visible pages, and anti-wraparound vacuums were causing IO storms. And when you had inheritance-based partitioning tables, and you need to manually vacuum and analyze your child tables. Tail truncation in the vacuumings happens silently, which stalls the reads on the replicas. And there was no auto vacuum and the vacuum counters of our specific tables. PG18 addressed all of these pain points with this release. So now you have a new asynchronous I/O subsystem, which helps vacuums to read ahead while processing. You can now adjust auto vacuum max workers on the fly without a restart. Now the larger tables can accumulate up to 100 millions of dead rows based on the default settings, and it will trigger an auto vacuum workers immediately afterwards. Eager freezing allow you to spread the freezing activity across the all vacuum runs so that it will reduce the IO strengths caused by the anti-wraparound vacuums. Vacuum and analyze on the inheritance-based partition tables can now include the partition by defaults. And you have a global settings for controlling the truncation, tail shrinking activity in the vacuuming. And you also have the counters for vacuuming and analyze in PG style all user tables. Let's start with each one of these features in more details in upcoming slides. We're going to start with the asynchronous IO for vacuum. This is the headline feature release for PostgreSQL 18. And this also helps the vacuuming. It's a game changer for anyone who is dealing with the high latency storage. And what I think is in cloud era, most of us are dealing with the similar problems. So prior to PG18, vacuums heap scans were entirely synchronous. It has to request a page from the disk and wait for that IO to get complete, then process it, and then request for the next page. On network style storage like Cloud Disk, NFS, SAN, this wait time adds up dramatically. With PG18, now the vacuum heap scan can prefetches the pages where it's currently processing. And while it's working on one set of page, it can request the another set of page from the disk. And this asynchronous IO behavior has been controlled by the two settings. By one of these is IO method by default set to worker, which spawns the dedicated IO workers for for doing this work. And then you have IO worker, which has been set to default 3. And if you see your vacuums, heap scans are taking longer time in PostgreSQL, then you can think of scaling this IO workers from 3 to 6. And even if you have a larger system, you can go up to 12. So the key takeaway from here is that you get faster vacuums out of the box without making any configuration changes. And the settings are available for you just in case if you wanted to scale further. Now we're going to talk about flexible auto vacuum scaling. This is one of the long-standing pain point every experienced DBA has ran into. So the problem was, like, let me walk you through this problem. So you have a busy production day, and you are seeing that bloat has been increasing on the tables significantly. And while you looked into the things, that you have realized that all of your auto vacuum workers has been working on the large tables. And you need new workers to spin up that can do the further uh, vacuuming activity on your server. To do that, you would require, prior to PG18, you would require a full restart window or maintenance window to do this change, or you could have done this manual work. But with the PG18, now you can dynamically scale your auto vacuum max workers. And how it is done, the auto vacuums gives you the one more setting, which is auto vacuum worker slots. And this setting controls the worker pool, and this has been configured during the startup. So it has been configured as 16. So I don't think you will need a change. You need to make a change after you have these settings enabled by default. And you can only adjust the auto vacuum max workers by default, which is set to 3. You can scale even higher when it's required. You can decrease it when it's not needed. The only thing which you need to keep in mind while you're scaling and descaling the workers is all of these workers have been sharing the same cost limit and delays. So in case if you are making any adjustment to the max workers, you also need to scale the cost limit. If you are scaling higher, you need to also adjust the cost limit so that each worker get the specific cost, and so it can do its works efficiently. Else, if you just keep increasing the workers without making any changes to the cost limits, it's going to slow down the existing workers, and overall vacuum activity on the tables will be slowed down. Now we're going to talk about the hard cap on dead tuples. So this is one of the why we didn't have this feature before, kind of a feature. So it's simple change, but it's also a great problem for the large PostgreSQL deployments. So the problem is the auto vacuum has to trigger on a table based on the certain threshold. The dead tuple has to exceed the rel tuples multiplied by the scale factor plus vacuum thresholds. And this has to be, so think that you have a 1 billion rows table with the default auto vacuum setting, which is 20% scale factor. You will require a 200 million dead tuples on a table to trigger an auto vacuum. 200 million dead tuples sitting on a table, consuming a lot of storage, slowing down all of your queries. And with PG18, this now gets solved with the new settings, which is like a max ceiling of dead tuples on any of the table. And the parameter called auto vacuum max threshold. This can be set on the instance level. You can set it to conservatively 50 million or lower when you wanted to trigger vacuum faster on your tables. So this can be even done on the specific tables. You can even disable this for specific tables. So all of these SQL statement here is an example that the way you can do it. Yeah, this is a simple change, but it solves a very great problem of silent bloat on large PostgreSQL deployments. Now we're going to talk about eager freezing. This is one of the long-standing operational headaches for anti-wraparound IO storms. So prior to PG18, the normal vacuums often skip all visible pages, thinking that it doesn't have to clear anything there. But those pages might have unfrozen tuples. And over the period of time, these unfrozen tuples accumulate drastically. And when a server reaches a wraparound thresholds, a PostgreSQL force aggressive vacuum on the aggressive vacuums that scans all pages, including the pages which has been marked as all visible. And these anti-wraparound vacuums are heavy, consume a lot more I/O, and can hold resources for extended period of time. With PG18, now the normal vacuums can proactively freeze tuples during the normal runs. And this setting has been controlled by the eager freeze failure rate, which is vacuum max eager freeze failure rate, which has been set to by default 3%. This spreads the freezing work across the normal vacuum runs instead of saving it all for a one big IO storm. You can set this on an instance level. You can even set this higher on aggressive tables, hot tables, or you can disable it. So some of the SQL examples are here, how you can do this change. Now we're going to talk about vacuum and analyze recurs by default. So this is one of those quality of life improvements when people are dealing with partitioning tables. And with the size of the data is growing, I think everybody is now dealing with the partitioning, and everybody has experienced dealing with the partitioning. So prior to PG18, inheritance-based partitioning, when you run vacuum analyze on the parent tables, you need to also do the child tables vacuuming separately than the parent tables. And this was an operational headache. You need to build your own scripts to do this. But with the PG18, now inheritance-based partitioning, when you do a vacuum analyze on a parent, it recurs the child tables by default. And if you wanted to fall back to previous behavior, you just want to do the parent vacuuming analyze, you can use the only keywords. So there are examples available in the SQL statements, which you can see how you can do the vacuum or analyze statements. With the declarative partitioning, we have one more twist. Now, when you do the analyze on a parent table for declarative partitioning, it will recurse all the child tables, and which you don't want to do on a busy production day. If you have, let's say, like busy full production day going on, if you just want to analyze this type of parent table, you don't want to go ahead and scan all the child table which has been available. So for that, you have an option of now, like you can only specify analyze only keywords, and it will only scan the parent table stats. Now we're going to talk about vacuum truncate. This is a global setting which has been available in PG18. So this makes the vacuum tail shrinking predictable. And this is the feature needed for the people who deals with read replica workload. So in earlier versions of PostgreSQL, when the auto vacuum finishes the table, it may shrink a tail, which means it may empty the pages from the end of the table storage. This sounds harmless, but it requires an access exclusive lock, which needs to be replayed to the replicas. And if you are using your replicas for the read workload, the reads on the replicas briefly stalled. And these creates a problem for your workload. With the PG18, you can now control this behavior more explicitly by turning this off on the instance level by just changing one switch vacuum underscore truncate. So this solves a silent problem where the replicas were getting stalled from the primary whenever there is a vacuum activity. And you can turn it off whenever it's needed. You can turn it on whenever it's required. There are ways you can do this on the specific tables. Like you can set this on the off on the tables, or you can set this on the tables. So yeah, there are configuration available, or SQL statements are there as an example to make this change. Now we're going to talk about one of the biggest observability change, which was required for all of the DBAs or the people, they wants to have more visibility around the vacuuming areas. So they want to really see where the vacuuming timings are really going. So now you have a 4 new counters in the pgstat all tables. So you get the total vacuum time, you get the total auto vacuum time, you get the total analyzed time, total auto analyzed time. So this now enables you to really look into the what are the top tables which has been where the vacuum is doing its job. Yeah. So I was talking about the new setting, which was track cost delay timing, right? So this is a new setting which has been available since PG18. And this setting is basically allow you to look into the delay timings of your vacuum progress. So this has been disabled by default for performance reasons. You can, when it's enabled, you can look into pgstat progress vacuums and you can look for the column delay timings. And you can, with this, you can really fine tune your cost delays for the tables, which has been like taking a lot of time due to the aggressive or the lower cost delay timings. Analyze now can also give you more verbose information of the values, the CPU time and the average read rate. So now it can give you much more insights than just simple telling you that analyze has been completed on a table. There is a new security role improvement also happened, which is PG signal auto vacuum workers. Now it can allow the non-super users to signal the auto vacuum workers, which means you don't have to really give anybody super user privilege to handle the auto vacuums. And this is the quick reference of all the parameters changes with respect to vacuuming in PG18. And some of them are startup parameters, some of them are dynamic parameters. So AIO parameters are common for vacuuming and the normal IO operations. So I'll not go for I'll not go list down each and every one. You just so this list is there. You can explore it when you have PG18 deployments. You can explore all of these parameters. The key takeaways. So let me bring it all together here. So we discussed about a lot of good improvements in PG18. So PG18 makes vacuum faster, predictable, and easier to tune. The AIO IO subsystem helps the vacuuming scale further. And max workers, dynamic scaling of the max workers allow you to take vacuuming control much more granular ways. Earlier it was you have to deal with the maintenance window and taking the restarts and doing it. Hard caps and the eager phasing is enabled by defaults. And explicit tail shrinking now has a better control. And you have better observability. And so net effect is like you get a smoother auto vacuum, shorter aggressive vacuums, and fewer locks on your application, fewer locks for your application workloads. Some of the resources and the references which has been, I've kept it here. These has been helped me to build this presentation for you. So this is one of my blog which has been written recently, PG18 vacuuming improvement explained. So this has much more details about each feature what we have talked about here. Then you also have PostgreSQL 18 release notes. Then we have vacuuming documentation. Then we also have auto vacuum tuning. This is one of our go-to doc when you're dealing with the auto vacuum issues in PostgreSQL. And thank you all. Thank you for your time. And now I'm happy to take questions. All of you can reach out to me on LinkedIn. My LinkedIn link is there on the slides. And you can also refer to my blog, PG18 Vacuuming, for more details. And thank you.